Welcome you students. I come up with another question. Block A 2 kilonewton and block B 0.8 kilonewton rest on a horizontal plane. Block B on the top of the block A. Block B is on the top of block A. Block B attached to a vertical wall. Block B which is attached to the vertical wall by inclined string. The string is inclined. It is with a string and which makes 30 degree with the horizontal. With the horizontal, it is making 30 degree. What should be the value of horizontal force P to cause the motion of the lower block to impend? Impend in the sense it tends to move or it start moving. When it start move, it is given. It is horizontally moving and towards the right side. So here given when the question itself, we can take weight A which is given 2 kilonewton and weight B which is given 0.8 kilonewton, and we have mu value all the surfaces between the horizontal surface and this block as well, between the blocks, all for all the surfaces the mu value is given as 2.28. okay, fine. To find the force when the block just impend, start moving, that we are going to find it out. Solution: free body diagram. Okay, when you come to the free body diagram, first take the block A. Always take the lower block. So here the block is something like this. Block is something like this. Okay, and if I put the axis with respect to the center, it will be something like this. Always the self weight of the block will act downwards. It is 2 kilonewton, and the applied force is right side, which is P. Then when it is having contact, there will be a normal reaction, that is NA, and friction force will be there. Just remember, the force is acting, the P force is acting just horizontally right side. So motion is towards right. Since it is just pulling the block something like this, what happens? The motion is right. If the motion is right, then the opposing force called friction will be towards left. So here itself we can put the magnitude of friction at A. The friction at A which is equal to mu into normal reaction at A. So here when you having the top, there as well we are having contact. So the contact region will have normal reaction. Okay, normal reaction, here it moves inwards something like this. Here as well the normal reaction will be moving what, just downwards. It is normal reaction because of this block B. So NB, okay, NB, and here the friction also just to the left side, just moving opposite to the the motion. So FB friction about the, because of this point block B, which is equal to mu into NB. That also we can write here. Then if you take the block B, top of it, the block is something like this, and here the string is attached and which is just inclined 30 degree. Always the tension force moves outwards from the center, so from it I just have considered outwards. So if I put the axis, the weight of the body will be downwards. Weight is 0.8 kilonewton, and the point P, and between the A and B there is a contact, so there will be a normal reaction. Okay, this normal reaction is NB, normal reaction at NB, and the friction force will be there. So friction force, see, always here the tension force is just pulling it to the where left side, am I right? And the P force will be pulling it to the right side. So the body B will be just keeping this position right in the same place because of this tension. So it experience just what towards the, so here see the tension force is just acting towards the left side, and here the P force on the lower block is acting towards the right side. So when it moves, it just try to hold its position. Okay, so this is because of this tension force. So here the tension force actually just opposite to the block A. Here because of this tension force here on it, it will be acting just right side. The tension force is just holding the body, just pulling it in the left side. So the friction force will be acting toward the right side. When you are having two blocks, just keep it in your mind, always just it will be opposite to the block A, lower block. The friction force will be opposite to the lower block. Here the friction force is towards left, so here will be right. It's a trick to identify it. So F B, which is equal to mu into N B. Okay, these are the forces will be acting here in this system. Okay, let it be. Next, we shall consider the block. I just going to consider the block B. Why? Because it has the minimum number of unknown forces. So here's the NB, FB, NA, friction A and P. 1, 2, 3, 4, 5. 5 number of forces are unknown. Here see 1, 2, 3. Only 3 forces are unknown. So minimum number of forces is a block B. So we have to move with the minimum number of force. Right? I have selected the block B. So here if I take the forces, if I simplify it, I can say there is a downward force 0.8 kilonewton, and there is upward force, that is NB, and there is a right side force FP, which is mu NB, and here the tension force is just inclined something like this. So I can predict it is vertically up and horizontally left. So T cos 30 degree, and here T sin 30 degree. Okay, this is how we need to take all the forces. So here apply equilibrium condition. Okay, so when you apply it, sum of horizontal force is equal to 0 and sum of vertical force is equal to 0. So first sum of horizontal force, which is equal to 0, I am going to apply here. So horizontal force, two of the horizontal forces are there. One is towards right and one is towards left. Right side force is a positive FB minus T cos 30 degree. T cos 30 degree is a negative direction, so it is negative, right? So here I cannot just simplify hereafter. So just I am substituting, and I just going to take this as equation number 1. So here FP is mu into NB. So mu is the 0.28. Mu is equal to 0.28. So I just going to take it into NB minus T cos 30 degree, which is equal to 0, and equation number 1. Then sum of vertical force is equal to 0. If I put it down, here the vertical force 0.8 kilonewton and NB and T sin 30 degree. Upward force is a positive, so here concern NB, which is upward force positive, and the tension force which is acting upward, that also positive, T sin 30 degree, and then 0.8 the self weight which is downward, so which is negative 0.8 which is equal to 0. So NB plus T sine 30 degree is equal to 0.8 when you simplify it. I just going to take it as consider as equation number 2. So now solve it. Solve 1 and 2. If you solve it with the help of calculator, it will ask me the answer for A1, B1 and C1 is a 0 and A2, B2 and C2 value. You will get the answer as NB which is equal to 0.688 kilonewton and you will get T is equal to 0.222 kilonewton. Okay, so you got NB and T. Our task is to identify the P force required to imprint the block A. So consider the block A. If I consider it, here we have all the vertical forces and horizontal forces, so we don't want to just simplify again. By seeing itself we can predict it, so let it be. So here if I put it the equilibrium condition, I just going to start with sum of vertical force is equal to 0. Here the number of vertical force is minimum, so I just going to take the vertical force first, so that we will get the conclusion, that means any of the answer. So I just going to take the sum of vertical force is equal to 0. So here upward force NA which is positive and 2 of the downward force which is negative minus NB minus 2 kilonewton. So NB answer we have it. Okay, so what happens? NA minus 0.688 minus 2 which is equal to 0. So here NA answer we can take it off. We get the answer as when you bring it to the next side, both will be positive sign. When you add it, we get 2.688 kilonewton. Okay, so this will be the answer. Then go with the sum of horizontal force is equal to 0. When you are doing it, horizontal force 1, 2, 3, 3 forces are horizontal, and the forces will be FB which is just minus direction, so it will be minus FB, and then FA which is directing towards the left side, so it is a negative sign FA, and then P force which is just directing right side, so it is a positive one which is equal to 0. FB mu into NB, right? Mu value is 0.28 into NB. In the place of FB I just going to put it off. NB answer we got here 0.688, so multiply minus FA mu into 0.28 into NA value we got here 2.688. okay, then plus P which is equal to 0. Now if you do the calculation here, we get the answer as 0.944 plus P which is equal to 0. Here it will be the minus answer. Okay, so when it taking to the next side, it will be 0.944 kilonewton. Okay, the answer for the force required to just imprint the block A, just move the block A is 0.944 kilonewton. So I hope you understood. Whenever we are having two blocks one over the another, just click down, separate it and identify the forces. Okay, all the forces, and keep it in your mind always. You always have to predict the force system from the lower block. Okay, so that's why I have taken this block A. If it is block B, I need to take this block B. Always you take the block which is at the lower side. So I have taken here the block A and I identify it. The friction force, it is so easy, just identify the motion where it is moving. Right opposite to it the friction will be. And here, when the block is at the top of anything, just when you don't have the enough identification, you can just put it what the friction just opposite to the considered friction on the lower portion. So here it is left side, so here it is a right side one. Okay, just put it and go with the block which has minimum number of unknown forces. So here the block B is having minimum number of unknown, so I have solved it. I got some of the answer, and just considering block A by substituting all the answer which we got in the previous block, just we will get the answer for the P force just required to embed the block A. I hope you understood. Thank you so much.